we're going to learn how to do a process called completing the square. For a warm-up here, we're going to determine the vertex of each of these quadratics. The first one is in its vertex form, so from the vertex form right away we know what the vertex is going to be and we're done. The vertex will be at positive 4, remember we want to switch the sign on that when it's attached to the x, comma 11. So the x-coordinate is 4, the y-coordinate is 11, and we know our parabola opens down if we wanted to do a sketch of that. The second example is in our standard form. We can't get the vertex really quickly, but the method we know at this point is we could take it to its factored form and then get the zeros, find their midpoint, sub it in, and get the y-coordinate of the vertex. There is no common factor for this. I'd be looking for two numbers that add to 3 and multiply to negative 28. And I believe negative 4 and positive 7 will do that. And because it's a simple trinomial, it has a 1 there, I can go directly to the factored form. My factors will be x take away 4 along with an x plus 7. That tells me then my zeros or x-intercepts are at positive 4, 0, remember switch the sign when it's attached to the x, and at negative 7, 0. And because parabolas are symmetrical, we know that the axis of symmetry is going to be exactly halfway between them. We need to find the midpoint. That will give us the x-coordinate of the vertex, or the h. So we're going to add these two values together. So 4 plus negative 7 would give me negative 3, and then divide by 2. Negative 3 divided by 2 is negative 1.5. Or you could leave it in fraction form and leave that as negative 3 halves. Then to get the y-coordinate of the vertex, or the k, we're going to take that value of h and sub it into the equation. So you can either put it into the original standard form, or you could sub it into your factored form. Either case, you should get the same answer. And when you sub that in and calculate it, you're going to get a value of negative 30.25. All right, so that tells us then that the vertex is at negative 1.5, comma, negative 30.25. Now this last example is also in standard form. No common factor for that. If I look for numbers, I'd be looking for two numbers that are going to add to 2 and multiply to 10. So thinking about that, 1 and 10 multiply to 10, but they're going to add to 11. And then we have 2 and 5, they multiply to 10, but they add to 7. So this one is not going to work. And we need to have another method to be able to come up with the vertex for it. Now I could put that into Desmos and then just check it that way. However, we're going to talk about this process called completing the square. Completing the square is used to convert the standard form of a quadratic into its vertex form. So an example like C, the factoring part won't work, so we have to go ahead and use another method to get there. Now we also need to understand what a perfect square is, or completing the square, what a perfect square is. So if I took the number 1 and I squared it, that would give me 1. 1 is a perfect square. 2, if I squared 2, 2 squared is 4. 4 is a perfect square. The reason 4 is a perfect square is because I can write it as 2 to the exponent of 2, another number to the exponent of 2. 1's a perfect square because I can write it as a base of something to the exponent of 2. My next perfect square would be 9, because 9 is the same thing as 3 to the exponent of 2. So any number that can be written as something to the exponent of 2 is a perfect square. So 1, 4, 9, and 16, these are all perfect squares. And I could keep going with that. If I translate that then into algebra, anything I can write with an exponent of 2 is a perfect square. So this is our perfect square. And we talked about this in our last unit. So that's a perfect square. The reason this is important is because when we have the vertex form has a perfect square embedded in it. We have a and then bracket x minus h all to the exponent of 2. There's the perfect square right here, and then our plus k. Now, if I actually square my binomial here, my x plus 4, if I square that, I know that I would have x plus 4 times x plus 4. I'm going to be nice and write this out twice. And x plus 4 times x plus 4 is going to give us an x squared plus 4x plus 4x. So remember, we double that product, and then we square the last. 4 times 4 is 16. So the shortcut for squaring a binomial was square the first. We're going to end up with twice the product. If I take x plus 4 and multiply them, I get the 4x, but it happens twice, so we get twice the product in the center, and then we have the square of the last. So anytime we want to work backwards, we want to take half of the middle term. So this 8x was twice or double the 4x. We're going to go half of that to get the 4x. If I take that 4, the coefficient of that, the 4, and square it, that's where this comes from. So when we look at completing the square, we're going to look at these first two terms. This obviously is not a perfect square because 10 is not a perfect square. But if I look at the very first two terms, I want to figure out what would I need to add to the 2x to make it into a perfect square. So let's do this process backwards. We're going to take half of the 2x, which is 1, and then I'm going to square that 1, and it gives me 1 again. That would make this factor as a perfect square, but I can't just randomly add 1 to an equation. I'm also going to subtract 1 so that it will be equivalent to the line before it. So I've added this extra plus 1 and minus 1 in. The net result of that is 0. And then my equation is identical to what I have above. So plus 10 and a plus 10. So the x squared plus 2x was above and the plus 10 was above, and our net result is 0. What we do with that is we lump the first three things together and factor it as a perfect square. So I'm going to square root the first, square root the last, and take the sign from the middle, all to the exponent of 2. And then I'm going to combine these last two terms together. So minus 1, add 10 is a plus 9. So now I get a vertex for that part C that I didn't have before, or I couldn't do by factoring. The vertex is at negative 1, 9. And you can check that on decimals, it will work. This is the example B from above. Now we did it through factoring, but I want to show you how we can do that with our completing the square. I'm going to lump the first two together. I'm going to take half of that x term. Half of 3 is 1.5. And then when I square the 1.5, I get 2.25. So I'm going to add 2.25, but then I'm going to subtract 2.25. And that net result is 0, and I still have the minus 28 on the end. I'm going to lump the first three together and factor them. That becomes my perfect square. That's going to be an x plus 1.5, square root the first, square root the first, square root the last, take the sign from the middle, all to the exponent of 2, sign from the middle, all to the exponent of 2, and then I'm going to combine the last two terms together. So in two lines, instead of the bazillion lines we had up above, the vertex is now at negative 1.5, switch the sign, negative 30.25, exactly what we had above. And we have 3 more examples that I want to do with you, but I'll do that on our next slide here. All right, here we are going to complete the square to express these in their vertex form. The very first one you should be able to do at this point following the steps from the previous examples, but when you get to part B and C, there's another thing we need to add to this because the coefficient of the x squared is not a 1. So if you want to try A on your own, put the video on pause, give it a shot, and then you can take a look at the take-up here. All right, to complete the square here, we look at these very first two terms. I want to take half of the 6. Half of 6 would be 3, and then square that, and we get 9. So 9 is the value we want to add and subtract to complete that square. So we're going to have our x squared minus 6x. We're going to add 9. That'll form the perfect square, but then we're subtracting 9 so that the net result is 0, and we're not actually changing the value of the equation from what we had above. Then we're going to lump the first three together. Remember, we always want the plus part to go with the perfect square. And when I factor that, square root the first, square root the last, and take the sign from the middle, all to the exponent of 2, and collect those like terms on the end. So our vertex form should be what we have written here, and the vertex is at positive 3, negative 13. Now, part B is different because of the 2 in front of that x squared. Remember your vertex form is y equals a, and then bracket a 1x in here, minus h all squared, plus k. The 2 in this standard form here is the a value. The 2 needs to come outside of the bracket in the vertex form. So our first step will actually be to common factor the 2 only out of the first 2 terms, the x squared term and the x term. So our first step will be to common factor 2 out of the 2x squared, so we are left with an x squared, and out of the minus 8x, we're left with minus 4x. So that's the very first step there, and we still have the plus 3 on the end. We don't need to take the 2 out of that. Now we want to figure out what we're going to add to the x squared minus 4x to complete that square. We're going to take half of that 4x, half of 4 is 2, and then when I square 2, I get 4. So we're going to add a 4 and then subtract a 4 on the end of that, and we still have our plus 3 on the end. Now, the perfect square part of this is these 3 components here. The minus 4 doesn't belong in the bracket with it, so we're going to kick it out of the bracket, and to kick it out, it's got to be multiplied by the 2 in front. So we're going to expand only the 2 with only the minus 4 at the end. So our next line will still have our 2 up front. It's going to have the x squared minus 4x plus 4. That's the perfect square part. But then we multiply the 2 with the minus 4 to get minus 8, and we kick it out of the bracket. It doesn't belong in there. Now we're ready to factor the perfect square. And to do that, I square root the first, I square root the last, and take the sign from the middle, all to the exponent of 2. And then I collect the minus 8 and the plus 3 to get a minus 5. So this one has a vertex at 2, positive 2, switch the sign, and then minus 5. We don't switch the sign on that one. All right, if you want to try C first, put the video on pause, give it a shot, and then you can watch the take-up here. All right, first step is we want to common factor the a value, which is negative 3, out of just the x squared and the x term. So we get negative 3 bracket positive x squared minus a 4x. And then the minus 5 stays on the outside. We're going to complete the square, the x squared minus 4x. To complete it, take half of the 4, we get 2. 2 squared is 4. We're going to add a 4 and subtract a 4 inside the bracket with the x squared minus 4x. So we're going to add 4 and subtract 4. So that's that net result of 0. The minus 5 trails along the end. We're going to kick that minus 4 out of the bracket by multiplying the a with it. We'll have an x squared minus 4x plus 4. That's the perfect square component. And then a minus 3 times minus 4 would be a plus 12 minus 5 here. Now we're going to factor our perfect square. Oops. We have minus 3 bracket, square root the first, square root the last, take the sign from the middle, all to the exponent of 2. Plus 12 minus 5 is plus 7. So our vertex for this one would be at 2, 7. All right, I'm going to summarize those steps below here for you to put in your notes. All right, and with the magic of technology, I have the steps listed here for completing the square. So step 1 is right here. This is step 1, where I factored the a out of the first 2 terms. Step 2, I took half of the negative 4 and squared it, and I added and subtracted that value in the brackets here. So there's step 2. And then from there, I kicked the minus 4 out of the bracket by multiplying a with the last term. So there to there is my step 3, kicking that out of the bracket. And then my step 4 is to factor the perfect square and combine the last 2 terms, the like terms on the end. So hopefully that makes sense and you can understand the process of completing the square.